This is presentation for AirGesture by Artin Bogdanov and Mariam Goja. We're a small team of two with the experience in design and statistics. Quickly about the project again, we're trying to replicate traditional device mouse using sensor tile. The goal is to create user experience for human-computer interaction via the motion sensors and gesture commands. Problem we solved, we don't know yet. We're exploring how we can emphasize, but we think it's a cool idea to be able to control your laptop or desktop computer on the from the distance. This is our first report we've done on the setup and learn, and I will show you the progress within our second report. Again, we went through the tutorial 1 and 2 to understand how those measurements are acquired and how we can use them. We explored the options to manipulate the mouse over the screen, and here we have two basically samples of like how we use the motion detection to integrate it within our project. The questions that we ended up after the first few weeks is how we can establish the coordinates data synchronization between sensors and execution code, how to define initial state, how to manage the baseline, should we use machine learning for click and swipe recognition. So in the report 2 we did further progress. We created the input pipeline to get data, and we store it in the CSV file right now, and then we analyze CSV file further to perhaps train our model and visualize it. This is the we adjust also the measurements that we're getting. We had a question about, do we need to use displacement and acceleration or state machine for motion detection. Big question also was how we can kind of put together sensor tile data into the Python, and we use the serial library, and through the serial library we basically created this pipeline of the data that enters the Python code, which will eventually control the mouse movement. And then here the second part is like how we can take the how we can integrate what we got from the sensor tile in the like a serial in the serial library and move it towards the actual control itself. So the key features is the smooth rotation for cursor movement, quick abrupt left move, it's a click, quick abrupt right move, it's a left click, quick abrupt down is a scroll down, and move up. Questions that we tried to answer last time got by the way, they got a little bit like expanded during the weeks, but for the most of them we've kind of find the answers. We decided to stick with the state machine for the click detection instead of the displacement measurements, and we decided to stick with the acceleration and gyroscope inputs. Also about the machine learning, should we use it for the click? Maybe not for the click, but for the swipe recognition, that's what we're trying to do right now. Here we have our GitHub repository. We have basically the data, we have sensor tile data, we have source code. Here we keep our Jupyter notebook where we actually visualize and manipulate data to develop a model. We have a mouse mover Python code which actually controls the cursor on the screen. We have a serial reader, it's when we get the raw input, and we have a store data. It's basically code that allows us to export data into the third-party spreadsheet. So yeah, so this is the GitHub, And that's it. I also want to show you, if you have a little bit time, our Jupyter notebook that we're working
In this video,
on.
we attempt to present.
And so here I'm basically exporting the raw data, and then I infer new data, such as it's a delta. Basically, I try to measure a change compared to the previous state. Another thing, so here is the columns. You can see this is basically what we got from the sensor tile, and this what we kind of infer from it, right? We make additional calculations on top of it. Here is the values that we hold, and here's basically the analysis of the. So we basically transform those signals into the wave, and we try to analyze waves. And as you can see, each of these spikes, it symbolizes the movement, and we can clearly see that within the our visualization. And different movements have different patterns. Right now, it's only for this one we have only right swipe, but when I was analyzing left swipe, it will have little bit different structure of the spike. So the spike will go down and then up, not up and down. So that help us to understand that we can differentiate among different motions by looking at the structure of the spike. And on top of it, I added some filters to kind of distinguish when the spike goes beyond the mean. It's just the visualization techniques. Another thing that we've done is that we try to kind of expand on the feature inference and try to kind of take a look at the big picture of the data. For that, I kind of use this describe built-in function in Panda, where I can already get out of box mean, standard deviation, max value, minimum value, and so on. And what I did, I took these measurements for swipe right clicks and for not swipe right clicks, like motions, and I tried to measure the change between them. And the change between them, why it's important, because I want to prioritize certain features based on the level of change they have before and after motion was detected. So that's where we're at. Again, I'm continuing the analyzing and seeing which features we need to select. Basically, that's the entire thing. And now we will need to move towards the basically define those features and try to build a model out of those features. Maybe on top of it using PCA, or just maybe stick with the max, min, standard deviation. I have a few questions, Jose. I noticed that your availability is only on Wednesday morning, but I was hoping maybe we can meet, let's say, Tuesday, around 4 p.m. Eastern time and 1 p.m. Pacific time. I would love to do this call even earlier, but I have an exam with my another class. So I was hoping if you can allocate me time, because I have some questions about the model. And the last calls that I had with you brought so much clarity, and I was hoping if you're available on Tuesday 4 p.m. to have a call and go over the model, go over the approach one more time with me to make sure that on Wednesday, by Wednesday, we'll be able to accumulate this knowledge and transfer it to the good model to showcase to the our classmates. Anyway, that's about it. Thank you so much for um, giving opportunity to be in your class and teaching and supporting us. And looking forward to talk to you soon. Bye bye.